instead of using SAS or ASA, consider writing the words out, unless you're just really confident. Okay, so postulate 14 is angle, side angle congruence. And then theorem. Do you remember how we get from postulate to theorem? What's the difference? Moses, you remember we just touched on it really briefly. Right, yeah, so one of them takes us then to like a firm statement that we can make. All right, angle, side congruence theorem. So now we've got SSS, SAS, ASA, and now we're going to have AAS. If you do not have these in your index cards, they need to be, so that you can make sure you get those letters exactly right. All right, here we go. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side. Boy, this makes exciting bedtime reading. If you ever are trying to go to sleep at night, I would suggest you get your postulates out and read them and your theorems. You have fun doing that? I was just kidding, Moses. Then the two triangles are congruent. So what we're working for here is we're looking for all these rules that can help us identify when triangles are congruent. So now we have angle, side angle. And if you understood the others, my guess is you're probably going to understand these pretty well. And angle, side. All right. And then they give us some examples between each one of those. So if you look up at the top at page 251, they give us an example there. And it shows in A and B. Let me just make sure that all of those. A, I believe, is the one that's, the one that's congruent. So if you look at that, and now a lot of times they draw the triangles. And I tried to talk about this in my video. So they draw the triangles where they're not necessarily looking like they would be congruent, right? I don't sit them side by side like this. And you look at those and you're like, yeah, those are congruent. Instead, they draw them, this one's kind of laying on its side, this one's sitting up. And it's harder to tell. So you have to figure out what the corresponding angles and sides are. So this one was A, B, C, and the next one was F, E, D. Now let me ask you a question. Actually, it would be easier to do. Look at this one. All right, ignore this guy right here. Ignore him. Well, kind of. You can ignore him. Okay, you're looking at these two triangles. Now, if I wanted, and they look like they're congruent except for the little hump right there at the top because I didn't draw very well. But let's say that they're congruent. Now, if I said to you, A, B, C is congruent to F, D, E, would that be a true statement? Yes, it is really, really important that you now say these letters in such a way as to make it a true statement. Because I said A, B, C is congruent, what did I say, D, E, F? I actually started at the wrong corner. So I have to, it's just like if I'm spelling somebody's name correctly, you have to spell the triangle's name correctly. And because this angle is what's congruent to this angle, this is the start of its name, A, B, C. This has to be the start of this one's name, because these are the two that are congruent. And then if these two are congruent, this has to be the next one. So I can't just haphazardly say, oh yeah, BAC and FED, they're congruent, because now I have to be really cautious in the order that I'm saying those letters. And I did talk about that on the video, but I want to make sure that I do mention it, because if you write on a test that ABC is congruent to DFE, you're going to have points taken off, because you've got to make sure that you're writing it in such a way so that I can tell that you've got those names exactly right. All right, now let's go back to this other guy. All right, so the way that they have drawn it now on page 251, they don't draw them nice in mirror image, so we kind of have to figure out the angles. Yes? Yes. So they did kind of point out that angle C is what's congruent to angle F. Angle B is what's congruent to, C is congruent to E, B is congruent to F. And then they showed us what the congruent sides are. And so we know that one, yes?
That's not like triangle.
Yeah, I know, none of them, neither should be. Right, I'm using the example out of the book, example 1, and I didn't draw it as accurately. Like this should be an obtuse angle, so it doesn't really look like it. What I'm just pointing out there is that A and B in the book, A of example 1 is a congruent using the angle side angle. So 2 angles are congruent, and the side between them is congruent. This isn't that hard, right? Pretty easy. And then we have the same thing. For theorem 5.1, angle, angle, side. And so they show you 2 angles, but then it can be not an included side. It can be a side out in the middle of nowhere. And so this is one that allows then that you don't necessarily, so if these 2 are congruent and the sides between them are congruent, I don't even know if that's right. But in this case, you don't have to have a side in between. Okay? So look down there and you'll see that BC and DF are congruent. So now we have something that can allow for a side that isn't necessarily included or in between those angles. All right, let's take a look. Did the homework had you doing some proofs, right? How did that go? Pretty easy? Were you able to reach back in the recesses of your brain and find definitions, postulates, and theorems that helped you to solve things? Or did you forget things? It's been a month. Did we forget some? Oh, I hope you brought your index cards today, because I have a PowerPoint with like 40 things on that you guys have to figure out. So this will be fun for the unfair game, which I will explain to you in a minute, Joel. Okay, let me see what I want to do here. All right, let's just take a look at example number 3. Does the diagram give enough information to show that the triangles are congruent? If so, state the postulate or theorem you would use. So hopefully we're using the ones that we just learned. So look at A. Example number A. Everybody should be on page 252. So if you're not, you're moving to 252. Example 3, number A. Everybody see that? You got yours, Joel? Everybody opened up to that page. And what they want us to figure out, do we have enough information to show that the triangles are congruent? So I have 2 triangles there. Looks like kind of a bow tie. So kind of a little picture there. And they want to know, so I don't really want you to read down through the other information. I want you to use what's in your brain. I have 2 sides there that are congruent, and I have 2 angles that are congruent. But is there other information that they have not told you or that I have not told you? Don't look down through the solution yet. Just look at the bow tie. See if I can draw a bow tie. Hopefully I can. Here's my bow tie. Sort of. All right. Then they tell us that this side and this side are congruent. And then they tell us that this and this are congruent. Now, is there anything else up on that picture that could be congruent? Any other rules that we can use? Yes. Y. Vertical angles. That one was way back a while. So now I know that these two guys are also congruent. So now I have angle, angle, side. Do I have enough information to say that they're congruent? Yeah, I do. With 4 of these, SSS, SAS, AAS, and ASA, whatever, I should have something in there that tells me that that's congruent. All right, let's look at the next one. And we have something like this. So we have kind of this thing, and then we have this thing, and I know that this and this is equal. Now, is there anything else? I know that 2 sides are equal, but I don't know about this side and this side. What about this? Is it equal to itself? Because of which property? And I gave you a clue. Reflexive. So I have 2 sides. Now, do I have any information on these angles at all? Any information on the angles? No. So I can't just, create a side-side postulate. I need information about the angles. So this one would be a big fat no. I don't have enough information. And then finally, the next one, I guess I can draw this one too. Am my drawing getting better? I don't hear any comments from the peanut gallery. Didn't you guys just really miss geometry while you were out? Johnny, your head looked like it was shaking no. Was that right? Oh, okay, I thought I maybe misinterpreted that. Johnny, your head seems to want to go back to a bad habit. I know you guys were dying not being in geometry, right?
I actually kind of did some on my own.
Oh, are you trying to score brownie points?
No.
No.
I will have you know, I like geometry, I just don't like the form of logic.
Oh.
I also have like a new drawing.
Oh. Hey, whatever, whatever makes you jump in and get excited about it. All right, so let's take a look at C. And what information do they give us? They tell us that UZW, let me write these in. Uh-huh. Yeah, that's what I'm looking at. Let me write the WUZ and WX. All right. So they are probably giving us some information. Generally, that just means lines that are continuing. UZW is congruent to XWZ. And that's the alternate in, I see. If we continued to draw out from here, so when you see this, it just means you're going to continue to draw out. And if you're continuing to draw out, then you remember all of those interior, exterior angles and all of that. Remember that? No, this is a mess.
It doesn't say to draw out the middle.
It doesn't, but that's what those arrows. Oh, yeah, you're right. So I wouldn't draw that one out. So then you go back to those alternate interior angles. Of course, reflexive property, we know that, and alter interior angles again. So when you see those arrows, what are you guys doing back there? Your book fell. Then take your your ruler, and just draw longer lines, and that's when then you can use some of those other properties. Yes? Here and here and here. Well, that's what we would have figured out too, is that they were parallel. And what do we know about that? That we have some congruent things going on, and that's what alternate interior angles theorem would have included, that parallel piece. Okay? So feel free to draw on your diagrams and keep them going, and then look back to some of those lessons where we saw the longer lines. Okay, let me see if I want to try this one. Have any of you guys ever done the cat's cradle thing? Yeah, did you see that picture down there? All right, let's actually, I want to get to the unfair game because I want to have plenty of time to do that. And I want to read